So we are now going to do the question 6. It's about the simple interest rate. So either deposit a sum of money, which means that we don't know the principal, and then the interest rate is 5.5% per annum. And if the amount that either will receive after 4 years is this, then we need to find out what is our principal. So first of all, we need to write it down. What is our A, what is our P, what is our R, and what is our T. So our amount is equal to 235,216. The principal is unknown, and then the R is equal to 5.5%, and then the T is equal to for 4 years. So then we can use our formula to find out the interest. Simple interest is equal to PRT, and then we can calculate the interest, but this time we don't know the interest, but we can using the amount is equal to P plus I, and the principal plus the interest. So then we can substitute the interest formula into this I, which means that we can have A is equal to P plus PRT. Okay, so PRT is basically just the I, which is substitute the I to be PRT inside our formula. Then we can take out the P as the common factor. So we have the A is equal to the P times 1 plus RT. So then we can substitute all of the things. So we have 235,216 is equal to the P bracket times 1 plus R. R is 5.5%, and then the T is for 4 years. Okay, as we want to find out the P, so we're moving the whole thing to the left hand side. Then we have the P is equal to 235,216 divided by 1 plus 5.5% times 4. Then using your calculator, you can get 235,216 divided by bracket 1 plus 5.5% times 4. Then give you the answer is equal to 192,800. So now we try to do question 7. The principal 35,000 is invested at an interest rate 8% per annum for 9 months, and then it's compound monthly. So we need to find out the interest received. So first of all, what we want is the APRT or APRN. So A is the amount. Do we know the amount? No, we didn't. Do we know the principal? The principal is 35,000. What is the interest rate per period? Our period this time is compound monthly, so we need to calculate the interest rate per month. The interest rate per year is equal to 8%. So the interest rate per month is 8% divided by 12. So this is equal to, we don't need to calculate out, but we can simplify. This is equal to 2/3%. Okay, so the N is the number of the interest that we can get. So we save it for 9 months, and it's coming monthly. So in total, we take the interest for 9 times. So the N is equal to 9. Then we can use our formula. The amount is equal to the principal times 1 plus R% to the power of N, isn't it? So the amounts can be calculated by using 35,000 times 1 plus R%, which is 2/3% to the power of 9. So the A is equal to 35,000 times 1 plus 2/3%, and then to the power of 9. Calculate again. 35,000 plus 1 plus the 2% over 4 over 2% over 3, and then to the power of 9. Okay, then we can get the amount is equal to 37156.9. And then this is correct to the first decimal places. But actually what we want is the interest. So the interest can using the amount minus the principal. Then we have is 37156.9 minus the principal, 35,000. So we can get the interest is equal to 2157 to the nearest integer. Okay, so that's for question 7. Alright, so now we're going to do question 8. So the current value of a smartphone is 6,500 and is depreciated at a rate of 4% per month. So we need to find out the decay factor. So the decay factor is actually just using the 1 minus the rate. Okay, so 1 minus 4%. And if you calculate that, it's giving you 0.96. So 0.96 is our decay factor. You don't need to do any more calculations. So find the value of the phone after 1 year. So our formula of the new value is equal to the old value times the decay factor to the power of n, isn't it? So the new value is equal to the current value or the old value, which is 6,500 times our decay factor, which is 0.96, to the power of what? We want for 1 year, but actually our rate is per month, isn't it? So we have to the power of 12 because 1 year we got 12 months. So our the new value should be calculating by using 6,500 times 0.96 to the power of 12. Then we can get the new value is equal to 3983, and then it's correct to the nearest integer. Okay, so for number 9, if a number increased by 35% and then decreased by 52%, and the result is this. So which one is the old, which one is the new one? So before we have a number, this is the old number, and then it's increased by 35%, and then it's decreased by 52%, and then the result is 1944. So we want to find out what is the old number. So if we assume that the old number is x, so we let the old number be x. So we have the x times 1 plus 35%, we times the growth factor, and then we times its decayed, so we times the decay factor, which is 1 minus 52%, which is actually giving you the result, which is 1944. Okay, so we have x times 1.35 times 0.48 can give you 1944, so that we have the x is equal to 1944 divided by 1.35 times 0.48. We move the whole thing to the left-hand side. So remember that we need to calculate the denominator first, and then we do the division. So we need to using 1944 divided by the bracket 1.95 times 0.48 of the bracket. So the answer is very pretty, is 3,000. Okay, so for the last questions, in a city, the number of the day school students decreased by 40% from 2018 to 2019. So the number of day school students, we actually don't know that, isn't it? So in our timeline, we have 2018, we have 2019, we have 2020. I think that's the 3 things we have, right? So the number of day school students we don't know, so we set as x, and it's decreased by 14%. So decreased by 14% after passing the 2018, and it's increased by 6%. So it's plus 6%. So you need to find out the overall percentage change. So do you still remember that the percentage change is equal to the new value minus the old value divided by the old value times 100%, isn't it? So then we can using our new value is equal to the old value times our decay factor 1 minus 14% times our growth factor, which is 1 plus 6%. So the new value is equal to the old value with taking as x, so x times 0.86 times 1.06. Okay, so this is our new value. We can just substitute this new value back to our old equations. So our percentage change is equal to x times 0.86 times 1.06 minus the old value which is x. So minus the x divided by the old value, which is x as well. Then we times 100%. So now we have x as the common factor, so we can take that out. So take x out, then we adding a bracket. Then what we left on this part is only this 0.86 times 1.06. So we can write 0.86 times 1.06 minus the x. The x is being taken out, so it should be minus 1. Okay, then we divide by x as well. So the numerator and denominator both got x, so we can eliminate it. Then we times 100%. So using your calculator, 0.86 times 1.06 minus 1, then times 100, can get the answer is equal to the minus 8.84%. So try to use this video to do all of the exercise again, and then if you have any question, don't hesitate to ask me. Thank you. Bye-bye.